My name is Drew Martin, and I'm your moderator, so I'm going to just kick things off and then try to stay out of the way. My background is I have a company called Silicon Beach Advisors. I do strategic consulting for chief information officers and that type of thing. Been a CIO for Sony and Jack in the Box, Jenny Craig, and then Lytix or DriveCam, which kind of gave me some exposure to automotive and things like autonomous and video-based driver risk management, to name a few things. So with that, I'll just introduce the panel, and we had some great prep discussions. I think you'll find it very fascinating. I'll ask each panelist to introduce themselves and their company, and we'll circle back around with a few questions.
Hello, my name is Hank Scorney, and I've been in the software industry now probably 30 some years, I guess. But I'm a lot younger than that, just so you know. And a lot of that time in communications software, but the past 6 years, I've worked for a company named Aptiv, which is a $16 billion tier one automotive supplier, active safety systems, electrical systems for almost 80% of all vehicles worldwide. And then I headed up the communications and all the networking on the vehicle, plus all of the data analytics, including the data analytics for the ADAS systems for safety. And now I advise a venture capital firm called Up Partners, and based in Santa Monica. We're about a $500 million fund focused on transportation, air, land, sea, and logistics and fleet.
Hi, everyone. I'm Jamie Shield. I'm the co-founder and CTO of a company called Stable, which is a AI-based platform for modeling and optimizing networks of EV chargers. So currently, our models are being used to deploy about $5 billion of infrastructure in the US. This is by major retail chains, automotive OEMs, oil and gas, major debt finances, things like that. Prior to that, I was working at MIT on ultra-fast imaging for automotive and medical sensing, so ultra-fast being the order of billions or trillions of frames per second. And before that, I was working with several utility companies in New Zealand on some early drone systems for monitoring and surveillance of distributed energy assets, which is where I'm from. I'm from New Zealand. Nice to be here.
My name's, excuse me, Tom Caldwell. I'm the CTO of TechNiche. It's a small global company. We focus on mostly like fuel retail and convenience store, around critical asset maintenance, management, repair. They use our software for that. I've been in software 30 years now. I'm a geek that way. I've worked up at Redmond for Microsoft. I've been a director of engineering at Cisco Systems for over 11 years, and I've had a couple startups here in San Diego, AI startups even. And so love software, and look forward to talking about, we're in big oil, which is moving to big energy, so I'm up here today because we're heavily invested in EV charging and the transition to renewable energy. So.
And I am Ben Landon. I'm the VP of Business Development for a company called Cyngn. We do industrial autonomy solutions, so for enterprises that build manufacturing facilities, warehouses, so we're doing autonomous tuggers, forklifts, things of that nature. I actually come from the road autonomy space, though. My previous company was a deep learning startup that was acquired by Tesla for their autopilot efforts. And then prior to that, I actually worked in automotive before it was called mobility and before billions of dollars of funding went into it. I ran semiconductor product lines for Maxim Integrated for the automotive group there. So we, for example, did the power management chips that powered NVIDIA's first automotive chips going back almost 15 years ago. Yeah, that's me in a nutshell.
Awesome. Thank you, guys. And the panel, when we talk about the revolution happening in transportation, there's kind of two key themes, as we all know. There's EV, which is, a lot of sustainability and kind of infrastructure implications. And we've also got autonomy. And so the way the panel's kind of structured, there's a lot of overlap, which we'll get to, but on our bookends is more on the autonomy side. I would just ask a question. Are anyone working in the autonomy space here? Great. And then what about on the EV side? So a good blend, yeah. And I think the question we all have on autonomy is, what are some of the key barriers? That it always seems like one of those technologies, especially when you talk about full self-driving or total autonomy, always feels like it's 5 or 10 years away. So what are some of the key barriers to that? Maybe we'll start with Hank, come back to Ben, and you guys jump into it.
So, so at Aptiv, we had a fully autonomous division, which was a co-venture with Hyundai, and my group did a lot of the data analytics in support of that, including the image recognition systems. One of the challenges really is ultimately, and I happen to be my PhD's in biochemistry, and I used to work on drug chemistry in some neural medication. And, the brain is pretty amazing. And its compute power and its efficiency in compute power is absolutely amazing. And the ability to deal with the number of situations that you deal with in sort of open road driving, and not constrained driving, local, highway, off-road, et cetera, is phenomenal. And our compute power is just simply not there yet. So that's the first one. So what you're going to see is autonomy in constrained use cases a lot earlier than you're going to see autonomy in open roads. That's reliable, safe, And I can tell you, like, the accident that happened up in San Francisco is because somebody never trained the model for grandma falling on the street, okay, to be able to see that person, recognize it as a human, and not drive over her, right? So, I think that's the first one. The second one actually is one that I would continually have a debate with the autonomous group on, and that is actually ultimately the use case. I think one of the biggest problems with autonomy is the word autonomy to begin with. And so if you look at, for example, like eVTOLs and air taxis and whatnot, that's happening a lot faster than road autonomy, right? And there's a reason for that. There's something called air traffic control. And on the ground, that doesn't exist. And so, in conclusion, I'll just say, right, do you really want me to buy a $500,000 vehicle that has full autonomy in it once you get to that, and sit in the same traffic that I'm going to sit in today? Right? So what I really want is communication, to coordinate the entire system as well and communicate vehicle to vehicle.
So my two takeaways on that would be the model's learning and getting smart enough to be almost human-like. And the second thing you mentioned was that the infrastructure has to be at a certain point, or the domain has to be at a certain point. I think, Ben, you were talking about this the other day. So what are your thoughts on that?
Yeah, for me, the magic jargon word that you can all of this stems from is what's called the operational design domain, or the ODD, which basically takes into account everything that your vehicle needs to account for when it's driving. So that's its own capabilities, that's the weather, that's how flat the road is, how bumpy the road is, what kind of turns do I need to make. It encompasses everything. So there's a reason why we're seeing companies that today can sell automation in an automotive manufacturing facility where the product line is very strict, or the assembly line, the same thing has to happen day in and day out. You don't go from random point A in San Francisco to random point B in San Francisco with everything under the sun that could happen in between. You have a much more constrained ODD. So I think that's a huge factor. It plays into some of what Hank says. You're not going to see grandma fall over in the road when you're driving in Ford's manufacturing plant. So it also constrains what you need to train your AI models on, what kind of circumstances you need to deal with. I think one of the biggest issues in that case actually was not just the detecting of the woman who fell under the car. I think they did detect it, but then some weird things happened. There was a collision. There was a lot of chaos. She somehow got caught under the car. And the biggest issue was the car wasn't able to sense or know that it was dragging someone and then stop. Now, a human many would notice. It all depends, right? It all depends where this person is on the vehicle and who's driving. But those are things that are practically impossible to future-proof for. Whereas when you know the situations that you have to deal with because they're so much more constrained, because you're operating in a structured space, you're able to design for those, let alone the fact that if something absolutely inexplicable happens when you're going 5 miles per hour in a manufacturing facility, guess what? You get to slam on the brakes to avoid making sure anything terrible happens. You don't get to do that in a 18-wheeler going 70 miles an hour down the freeway. So all of those implications, they all stem back from that ODD, that operational design domain, and they completely impact everything from budget to severity of incidents to what you should or shouldn't need to plan for. And I think that's why we'll see road autonomy continue to be 5 to 10 years out on the horizon. But they'll figure out their own ODD constraints too, right? There's a reason Waymo does 50,000 rides a month now in Chandler, Arizona, not in New Delhi.
Right, right. And who here has a car that has any level of self-driving capability? Right. And I would say, as someone who has that in a Tesla, same thing happens. It does great until the road lines disappear, that you go through construction, and suddenly it's you and the Tesla are driving blind, down the highway. So I think one of the things in the domain is in the general sense, is the infrastructure. If the infrastructure is not at a certain level that can be reliable, then the self-driving can't be reliable. And maybe the third area that we didn't really touch on is the regulatory side of things. So when you're in your own manufacturing facility and you own it, you can set the rules around what kind of risks you want to take, for the most part, OSHA notwithstanding. And you can kind of make those decisions when you're dealing with an accident where we would never have heard about that accident if it wasn't an autonomous situation. So everyone's jumping in trying to figure out, from a regulatory point of view, how do you kind of get ahead of this? And it's always a challenge in emerging technology. So I'll ask the similar question to the folks who are dealing more on the EV side. And what's, one of the dreams out there is net zero, zero emissions and all that. So same thing, 5 to 10 years out, we're going to be, especially in California, we hope to be at net zero transportation. What are some of the barriers and limitations and roadblocks from preventing us from getting there?
Not to ignore your question, but I actually want to comment on the regulatory side
Please.
a little bit first. Yeah. Because I think it's interesting that the US-based autonomous technology is the best. It's definitely leading the world, and yet we're not leading the world in autonomous deployments. If you look at a lot of Asian markets like Singapore and China, they are outpacing us. And I think there is a lesson there that they have government support, very, very low regulations, a lot of incentive programs. There is broad consumer interest in this. They have a really thriving domestic OEM market, and they also have a really burgeoning middle class that cannot develop in the same way that the US middle class can in terms of vehicle ownership per person. They simply do not have the road capacity for it. And so there is much, much more desire for shared autonomous systems in those markets and broad government support. You compare that to the US, and there is a lot of public lack of support for autonomous systems. There is tight regulations, and we're holding these systems to an incredibly high technical bar, which is in the end good, as we just spoke about. But there's an argument to be made that it could be a little bit too high. I'm curious if you have any thoughts on that.
Yeah, I was just going to add into infrastructure.
Yeah.
Right. To your point, in China, the amount of infrastructure investment, we're not even on the map.
Yeah, exactly.
Sorry.
No, I think Jamie touched on some good points there, and I think the regulatory piece is certainly a problem. I mean, it's, like was just said, you wouldn't even have heard about this accident if it wasn't because it was an autonomous vehicle. Now, they should be held to a high standard, but at the same time, they should not be, scrutinized to the level that it's being slowed down. And that's, again, that's why I think it goes back to the operational design domain. It's why we're focusing in closed spaces where essentially our customer is our governor. right? We don't need to go through the DMV or NHTSA. We go to the site manager and we say, do you know that if we mounted a sensor on that corner, we could see around the corner and we wouldn't have to stop at the corner and slow down by 30 seconds every time we're pulling a load to the start of your manufacturing line? And they can say, great, I'll put it in tomorrow, as opposed to, we'll deliberate over this and put it through 7 courts and we'll let you know in 6 years, right? So I think that is a major piece. And what you touched on too, in Singapore, Singapore, China, there's things that we can't even account for culturally in terms of willingness to adopt new technologies. You have people who, in the United States, who absolutely think that these are bad things that are going to introduce terrible stuff to our lives. We have our director of software autonomy came from a company called Bossa Nova, which deployed lots and lots of robots at Walmarts, and he said he had stories of, on camera, people pulling guns on the robot, people tackling the robot. So those have major implications, and the other side of that I think between Drew and Jamie, you guys mentioned, is the unit economics of it all, right? That all then ties into the unit economics. If you ask me, if your idea of an autonomous model is great, I now have a $500,000 car and it drives me everywhere, you're done. Just pack it up and go home. That's right. That's not what's going to happen. And so it does bring us to this. It has to be a shared fleet model for the unit economics to make sense, which means the fleets need to reduce their costs far more than they have been able to today, because recouping the upfront cost of a $300,000 vehicle that costs $50,000 a year to maintain is difficult when you want to beat Uber and charge 20 cents per mile. And that just opens up the entire, like, why it's going to be more delayed from a non-technical perspective.
I think on the EV charging infrastructure piece is there, and I've been watching fleets, and there's a company I was looking at, Green Lane. They're putting EV chargers down the I-15 corridor, and but again, you can't have islands of chargers. You have to have a full continuity to be able to recharge whatever vehicle it is, delivery, long-haul trucking, or whatever. But I think it's infrastructure, it's the supply chain to critical minerals, I hear, is holding back EV charging. And then just battery technology and hydrogen technology, it's still quickly evolving in the industry, so that needs to evolve a little bit more too before it becomes more mainstream.
And do you see one of those two, between hydrogen and electric, kind of becoming the de facto standard, or is it still up for debates or different use cases for the two?
I see EV charging evolving a little bit faster, but we do have some of our customers putting in hydrogen in certain areas, more in Europe right now, but I know California is planning a lot.
I can add on that as well. I think the use cases will just be slightly different. In transportation, right, it's not just road vehicles, although we're focusing on road vehicles. If we talk about the net zero question, in order of emissions, we have road vehicles at the top, aviation, maritime, and rail. And so we want to do all of those. But we have this chicken and egg problem with alternative fuels, where you have to get the vehicles out there, you have to also get all the support infrastructure. You can't really have one without the other. The reason electric vehicles, I think, have done so well is you can have at-home charging. So you kind of circumvent the infrastructure problem, or at least you allow it to lag a little bit. And we're seeing that very, very slowly catch up. But it's hard to justify hydrogen and consumer, lightweight passenger vehicles because of the infrastructure problem. It's just so big. You're not having a refueling station at home. But for things like aviation, for maritime and rail, the energy density of battery electric is just not there. So you're not going to be having these huge container ships run on battery electric. It's not anytime soon. And the infrastructure problem is also much less because you have point-to-point infrastructure. So you can build one hydrogen station at a port, maybe at another port as well, and you've got a point-to-point connection with only 2 pieces of infrastructure, and that could be a multi-billion-dollar shipping route for you. So the penetration is much, much easier for hydrogen in those long-haul scenarios. But the counterpoint is really expensive to R&D hydrogen. And we now have, hundreds of billions of dollars being funneled into battery electric research. So I think there's still an argument that battery electric could win just because of the R&D spend, but the energy density would have to be a whole lot higher to make that happen.
Yeah, I'm actually this infrastructure thing, it's funny how infrastructure keeps popping up. And I'll give you a little piece of data that we had from Aptiv for for all of our charging sets, is we did a study on trucking companies, for example, and in the Northeast, the average trucking company had 400 amp service. So what are you going to do? And the average trucking company is like somewhere around 18 trucks. You know, there's like a bunch of big ones, but the vast majority are, and the charging capacity for 18-wheelers roughly a megawatt. So, you know, 400 amp service is not going to cut it. You know, at Up Partners, we have a system where we'll do battery swapping on the trailer, which, so I think we're going to have to look for some innovative
I think in those corridors too, they can't just tap into the grid. They have to find sources of renewable energy, so they've got to form these partnerships for solar and all sorts of battery farms and things like that that are alternatives to tapping into the grid. You know?
Yeah, you mentioned the grid. I just thought we'd touch on that. There's, you know, and again, to my broader question of when do we get to, you know, net zero, one of the things that's implied in there is that the grid or home charging collectively will be able to satisfy the demand, not just in the individual trucking depots, but more broadly for EV. Any outlook on that, or?
Yeah, I mean, it's a huge issue. Just to put it in perspective for everyone. So if you look at the US energy generation capacity today, we have about 4 trillion kilowatt hours per year being generated. If you were to transition all of just our light duty passenger vehicles, so not looking at any of the other aspects we just spoke about, just light duty passenger, you would need about another 1 trillion kilowatt hours. So this is a huge amount of energy going in, and that doesn't include all of the additional transmission, distribution, all the interconnects. And of course, we want most of that excess energy to be renewable. We don't want to be installing renewable sources. These are much more expensive than coal systems, even natural gas systems. And so there are a lot of estimates out there. They're all over the place, but typically they're around $1 trillion just for energy capacity, again, not including any of the load balancing, which is a huge issue for things like solar. So we're talking at like multi-trillion dollars investment to get this done. And that's not even including things like AI. You know, I think Goldman Sachs had a report last week that said that AI by 2030 is going to double its energy requirements for data centers. That's going to keep doubling in the future. These are huge data points because the US has not changed its power requirements for the last 20 years. If you look at the variation in power requirements, it basically hasn't moved for 20 years. And now we're on a precipice of a huge amount of energy change. And everyone should care about this, by the way, because the cost of energy is really directly connected to the prosperity of a nation, because you use energy for everything. For all of our economic activity, we use energy. And a lot of it today in the US is domestic oil production. That's why we have such cheap energy in the US. But as we start replacing a lot of these systems with battery electric, if we're now trucking with battery electric, we're literally tying our ability to move our economic goods around our nation to the cost of energy. And so getting this right is super, super important. Making those investments in renewables, but making them sustainable is super important. I don't think we're there yet. I think we dive into that, but maybe I'll pause there.
Well, I don't know if you have any thoughts on what the solution might be. I know we've just spent a lot of money in the Inflation Reduction Act on infrastructure and build out, and nuclear is renewable, but not necessarily acceptable in the U.S. anyway. So I don't know if you have any insights into not just the problem, but also how you think the problem might be solved.
We have offices in the UK, so I spend a lot of time over there. And we also have customers putting in EV chargers all over the UK. But they have a lot of wind turbines that they're putting in. And we've talked to the power company, and they said they're surviving pretty well off the supplemental wind turbine energy that's coming, and they can support, they're putting in chargers faster than the US is right now. And so it looks like it's headed in the right direction.
Great. The one other area we didn't really talk about it, we have infrastructure is one of these non-sexy things that has to be in place for these things to work. The other one is interoperability, especially on the charging side. So we've got different adapters and that type of thing. I don't know, do you see anything moving in the industry to make sure that someone's looking at interoperability between EV and AV and those type of things?
Yeah, I think it's kind of a Venn diagram here of like software-based interoperability and then hardware-based interoperability. So in the world of autonomous vehicles, especially for us, and kind of my company's view on the world is, let's take a Walmart as an example because everybody understands Walmart. They have who knows how many types of vehicles, right? Forklifts and this kind of pickup truck and that kind of tow tractor and tons of them. So if you fast forward to whatever, how many years down the road, even if there is an autonomous solution from each one of those vehicle vendors, there is just no way that Walmart has 30 different autonomy vendors that provide it with 30 different vehicles, with 30 different data repos, with 30 different trainings, 30 different UXs. There's no way. So you have to ask yourself, how do you solve that problem? So there's a couple different ways. We, in our short-term thinking, try to be more of a software-defined vehicle so that we're kind of vehicle agnostic, right? Ultimately, we can get our technology targeted to any type of vehicle, and we've gotten it running on a dozen type of different vehicle form factors. But obviously, we're not going to cover every vehicle in the world under the sun forever. So now you have to start thinking more from a platform angle, right? Who can come in and say, okay, I don't care what company you are or what kind of solution you provide, I'm going to be the unifying data platform that is the abstraction layer between Walmart and these autonomy vendors, so Walmart can get all its data in the same place and create that kind of interoperability, connect to Oracle, connect to SAP, warehouse management systems and ERP systems. And so I think it plays out over a very, very long time. And then it starts to touch into EV as well, because all of these are going to have smart charging, and they're going to have different charging profiles, and they're going to have different charging needs, which then starts to segue a little bit into that hardware side of things too. But the management of telling them which charger to go to, and then figuring out the hardware interoperability question is kind of a tee up
Ben,
to you guys.
one thing I want to touch on that I know there was a lot of excitement about it a couple years ago at a university in Michigan. There was the study on vehicle-to-vehicle communication. If the vehicle, 10 vehicles up, slams on the brakes, and if you can't see it because you're behind an 18-wheeler, your car can stop. And vehicle-to-infrastructure. So if you didn't notice the stop sign or the red light, the infrastructure could communicate to your car. I know there's a lot of excitement about that, but that seems one area of standards and interoperability that could really influence how far we go with autonomy. I don't know, but then it seems to be one of those technologies that kind of, there's a lot of excitement and then maybe some challenges and less in favor. I don't know if you have any updates on that.
Well, I could tell you, V2V and V2X was part of my division, and it is completely died. There's basically no activity in it at this point. The problem with the automaker community is they still are highly proprietary. The concept of even APIs, standard operating systems, with the exception of the Chinese automakers and Tesla, just simply doesn't exist. I mean, it is unbelievable. If there was a doorknob to be designed right, you'd have 30 different doorknobs in your house, right? Every single one would work differently. So I'm not seeing that at all.
And
Again,
there's a catch-22 problem too, because I've argued with OEM procurement over tenths of pennies. And you're talking about put an entire communication module while you tell the city, no, I want you to use taxpayer money to install the infrastructure. But who unblocks that race, right?
A few great points in there just around unit economics. I think a lot of times when you're trying to figure out what's going to move the needle, just understand the unit economics. I'm going to just open it up. We got a few minutes left. I want to open up to if anybody has questions. I was happy to see those hands of people who are in autonomy and people who are in EV infrastructure side too. Any questions that people have for this great panel? No question. Oh, there we go. Question here. Sorry.
Hi, my name is Isabel. I'm in EV charging space, and I'm curious to hear your thoughts on consumer behavior and change in mind shift, change in how we fuel our cars with electricity or otherwise. What do you think? How is it going to change? What's the impact on the speed of adoption of autonomy or EVs?
The change from internal combustion to electric? Yeah. So Stable, basically, our job is to model this in a mathematical sense, and we have one of the best models for doing this. So I can speak great to this? This is a perfect question for me. So one of the things that we see going from internal combustion to electric is the kind of the mindset that you have when you are refueling. So if you think about you're driving your gas car and the fuel light comes on and you go, oh crap, I'm running out of gas. And so it's very reactionary. And then you go to a gas station. So it is a destination. You're going to a gas station to refuel. What we find in electric is that it is far more opportunistic. You're just topping it off every now and then. You might top it off at home. You might top it off when you're out of the gas station, when you're out, grocery shopping. And so because of that, it's also far more opportunistic. You're there. You see a plug-in charge, and so you plug it in. And so one of the things that we have to contend with is that makes forecasting demand way more challenging. So if we're trying to attract the $1 trillion of investment that we need here, debt financiers, they want to know what their return on investment is going to be. And suddenly, if you're trying to forecast when someone's going to go to a grocery store and plug in their Bolt for 30 minutes, really, really hard to figure out the return on investment. And if you're trying to create grid resiliency and you're trying to forecast demand, that's also really hard. So that's what my company does, is try to solve those two problems.
There was an aha moment when I was working with this panel that I started seeing the intersection of EV charging, software-defined vehicles, autonomy. It may not be full autonomy, but Tesla drivers are starting to enjoy that, and it's being built in all these autos. So it is interesting as this convergence happens. I think adoption will, take off also.
We had a hand in the back, too.
Hi, can you speak to how autonomous mobility is impacting the rail industry? I've got a train.
I think one area, one example, we know there's this real shortage of truck drivers. And so there's companies like Peloton, if you're familiar with them. But so you can get two trucks that just kind of, the second truck is just following the first truck. So you cut your labor costs in half essentially for that. So there's those type of things. And I think the more autonomous infrastructure is built in the roadways, we talk about a domain control. Train tracks are very domain controlled, right? So the more that kind of gets built up in the general space and on the roadways, I think that could provide some alternative. But of course, rail is pennies, fractions of pennies compared to what it takes for a truck. So I think those unit economics again are always going to be in your favor. So don't worry just yet.
I mean, I think most of it today that I know of is all around active safety systems, right, rather than true autonomy. Which can include remote operation, which is now already starting to get pretty widely deployed in construction, mining, other apps. So I can see that coming in as a backup and whatnot for rail. But
Well, so I interpreted the question though as how will autonomous cars impact the rail system, not how does autonomous technology impact autonomous train. And I think there's actually a lot of interesting questions to out there, right? Because you have to think about, why would I even take a certain mode of transportation? I'll take a train because it lets me read a book or do my work while I'm commuting to the place that I need to go. If you have an autonomous vehicle, you can do that now, right? You can sleep. I've modeled out the costs and the differences between, hey, I can now work in San Francisco and I can live in Sacramento, and it's fine if I wake up at 4 a.m. to hop into my autonomous vehicle because I'll be at work by 7 and I just get to sleep the rest of the way. Right, so that completely, those kinds of thoughts completely change the way that you approach it, because now you introduce a new problem. Well, no, the train's cheaper, so I'm fine with that, but now you have a last mile problem, right? How far is my train from the destination that I actually need to get to? So I think there's going to be a lot of interplay between them, and then it gets right back into these guys' camp of, well, how far can my autonomous vehicle go? Well, because your train can go across the entire country and you can sit on it and you don't have to move. What do you do if you want to take your autonomous vehicle 700 miles away? So I think there's a lot to unpack there that it's going to play out in an interesting way over the next couple decades, probably.
Since we're at time, I'll do one last speed round, and we are being filmed. So Ben, how long to full autonomy, general? How many years?
On the road?
Yes.
I'll caveat it by saying
No caveats. Come on.
It's there today with Waymo in Chandler if you constrain it. If you're talking the utopia of my kid doesn't need to get a driver's license anymore,
That one, yeah.
25 years.
Okay. Now, how about a full saturation of charging
Yeah, I think
in the U.S.?
I was going to say 10, but he influenced me on 25, so I think it's further out because renewable energy is going to take a little bit longer.
Okay, 25. Two 25s.
Goldman Sachs is 2040 to 2050, so I'm going to go safe with them.
Oh,
Assume
smart.
They did
The
their
smart money
homework.
says that. Autonomy, full autonomy. Kids don't need a driver's license.
25 or greater.
All right, there you have it. Not 5 or 10 years, 25. Thank you, everyone. Please give a hand to our great panel. Thank you for coming.